Today we are going to integrate x squared over the root of 5 minus x squared with respect to x. We must first use a trig substitution to solve this. We let x equal the square root of 5 times sine theta. This means that dx is root 5 times cosine theta, and also means that the root of 5 minus x squared equals root 5 cosine theta. Now we substitute this in. Simplifying, this equals the integral of 5 times sine squared theta d theta. We can now change the sine squared into 1 minus cosine 2 theta all over 2. This allows us to integrate. Solving, this equals 5 times half of theta plus 1/4 of sine 2 theta plus c. This is equal to, when substituting back into x, 1/2 of the sine inverse of x over root 5 minus 2 sine theta cosine theta all over 2 plus c. This is equal to 5 times 1/2 sine inverse of x over root 5. And to solve for sine theta and cosine theta, we must draw a triangle. We see that sine theta is x over root 5, and cosine theta is root 5 minus x squared over root 5. Solving, we get x times the root of 5 minus x squared all over 5, plus c. Simplifying once more, we get 5/2 sine inverse of x over root 5 minus x times the square root of 5 minus x squared plus c. Common mistakes include substituting the Rotring function and drawing the triangle incorrectly.
Hello. In this problem, we're going to be integrating tangent cubed of x. So to start off, we want to split this up into the integral of tangent x times tangent squared of x, dx. And then we can rewrite that as tangent x times the identity for tangent squared of x, which is secant squared of x minus 1. And don't forget the dx. So now we can multiply the tangent of x into that secant squared of x minus 1, and we'll actually get two separate integrals. Tangent x secant squared of x dx minus the integral of tangent x dx. And now let's go ahead and solve that first one. So we're going to use a u substitution for this, letting u be tangent of x, so that du will be secant squared of x. And now we can rewrite this integral as u du, because our tangent x is u and our secant squared of x is du. So I'm just drawing the arrow there to show that's where my work is going next. And this equals u squared over 2 plus c, because now that we've integrated, we have a constant. And substituting tangent of x back in for u, we get tangent squared of x over 2 plus c. So now let's solve that other integral a negative integral of tangent of x dx. And we get negative ln of cosine x, absolute value of cosine x. Now this is an integral that we memorize. You can check and see that that is true, but that is just something you should have memorized. So our answer is just going to be the sum of these two. Tangent squared of x over 2 minus ln of absolute value of cosine x. Now, here's a mistake I made. I said minus, but we're actually subtracting that negative, so it should be plus. And then we end with a plus c as well. So that's our final answer.
Hello, Blake Currier, and today we will be integrating 3x squared minus 10x plus 8 over x minus 1 cubed dx. It's a PFD. It is a repeating polynomial, so be very careful. We do not want to do ax plus b, cx plus d, etc. It is not a repeating quadratic. That would be wrong. So we're just going to have a, b, and c. Now we want to take our time with the factoring. It can be easy to make mistakes here, so we will just go slowly and deliberately until we have our fully factored out equation of ax squared minus 2ax plus a plus bx minus b plus c. Now we also want to take our time with finding the variables a, b, and c, so we set up a nice little grid to find the x squared, the x, and the coefficient. So we already have a equals 3, so just plug that straight in to find b, and our b will be negative 4. Plug in a and b, and we get 3 plus 4 plus c equals 8, so our c will be 1. Again, be sure to take your time finding the variables. Now, we're just going to set up the integrations. So we have 3 over x minus 1 dx minus 4 over x minus 1 squared dx plus 1 over x minus 1 cubed dx. Now this first one is going to be pretty simple. We've all seen it before, and you can pretty much go straight into putting it as 3 ln of x minus 1 plus c. Don't forget the plus c. Now our second one is going to be a little trickier, but it's pretty much a simple u substitution. We'll just let u equal x minus 1. You get 1 over u squared du, and we'll just set that equal to negative 4 over x minus, not plus, be careful with your signs, minus 1 plus c. Now we will do the 1 over x minus 1 cubed dx. So we're going to let u equal x minus 1 again. So we'll get 1 over u cubed du, which will be equal to negative 1 over 2x minus 1 squared plus c. Now all of the c's will overall just become 1 plus c. So we have 3 ln x minus 1 minus 4 over x minus 1 minus 1 over 2x minus 1 squared plus c. Be very careful with those positives and negatives, and we have our answer. Just clean that up a little bit. There we go. All right.
First, we must recognize that this is an improper integral. So in order to solve it, we will need to implement the limit as t goes to infinity of the integral from 1 to t. Then, one key tip is that for whenever you see an ln x in the numerator and an x in the denominator, it's a classic u substitution type question. Another thing is one must also remember to change the bounds of the integral when using u substitution. This is a common mistake and will usually lead to an incorrect conclusion. We have to also take into consideration that we can also go back and resubstitute u for ln t. Both methods will yield the same final limit. Lastly, another common mistake is getting positive infinity and then, as we will see, forgetting to conclude divergence. First, we must realize that this is an arc length problem with the integral of the square root of 1 plus dy dx squared. To save some time, we will skip the algebraic simplification, which includes first squaring, then canceling out 4's, and then we rewrite 1 as 1 minus x squared over itself, and then combine like terms. Finally, we will show how to solve this using trigonometric substitution as an alternate solution. Note, however, that this is actually a known integral of sine inverse. Whenever doing a trig substitution, a quick sketch of a triangle is a helpful tip for visualizing the problem. The rest is fairly simple, and you can either solve the integrated component in terms of theta or rewrite it in terms of sine inverse.